In this video, we will talk about the adjoint of the matrix, which is sometimes called adjugate of the matrix. So, if we are given a square matrix, you can call it Aij, a square matrix of order n by n. Then the adjoint of the matrix can be defined in this way: capital Aij, where capital Aij is the transpose of the cofactor matrix. What is the transpose of the cofactor matrix? So first of all, we will learn what is cofactor matrix. The cofactor matrix of Aij is defined as -1 to the power I plus j. For every Aij, the cofactor is -1 to the power Aij times the minor Aij. So what is the minor? The minor of Aij is obtained by deleting the ith row and the jth column. Okay, deleting the ith row and the jth column. If you delete ith row and the jth column of the matrix and you take the determinant of the rest of the submatrix, that is called the minor of Aij. We will do an example. So in this example, we have to find the adjoint. So in order to find the adjoint, we need all the cofactors and all the minors. So first of all, we will compute all the minors. So what is the minor? I told you the minor is obtained by deleting ith row and the jth column. Okay. So there are total 9 elements in this matrix. So we will need all 9 all minors. So first of all, we will talk about M11. So in order to find the M11, so for the M11, this is the first row and the first column. So I will delete this and find the determinant of this submatrix 2 minus 1 0 4. So you can check it is 2 minus 1 0 4. If I calculate this determinant, I will get this is equal to 8. So the next minor is M12. In order to find M12, so this is 1 and this is 2. So this is the element, first row and the second column. So if I delete 1 row and 2 column, the rest is -5, -1, 3 and 4. So -5, -1, 3 and 4. You can check. This is M12. So if I calculate its value, I will get -17. Next we have M13. In order to find M13, I will again delete first row and the third column because it is M13. So first row and the third column. So this is the submatrix whose determinant is to be found here. So I have written that submatrix. So in order to find its determinant, we will calculate the value, which is -6. The next one is, so this is M1, M11, M12, M13. Okay. And this is M21, M22, M23. And what is this? M31, M32, M33. Okay, we will find all of these minors. So what is M21? M21 means second row and the first column. This is the second row and this is the first column. What is left? This is left and this is left. 02 and 04. You can check. Here we have 02 and 04. If we calculate its determinant, we will get 0. Similarly, we will get all of the minors. You can calculate. I have written them directly. And then since we have found all of the minors, now we will find all of the cofactors. Okay. So here is the formula for the cofactors. This is the formula. So the first cofactor is A11. we have similarly a11, a12, a13 up to so on. Similarly a21, a22, a23 and a31, a32, a33. So the first one is a11. So the formula for a11 is negative 1 to the power 1 plus 1 times the minor m11. So what is negative 1 to the power 1 plus 1? 1 plus 1 is 2, so negative 1 to the power 2. 2 is even number, so we will have plus. So I will write plus m11. So m11 is already found. Here is m11, which is 8. So I will write this is equal to 8. Now is the turn for a12. I will write the same formula. Negative 1 to the power 1 plus 2 times m12. Since 1 plus 2 is 3, so negative 1 to the power 3 is odd. Whenever you have negative 1 to the power odd number, you will get negative. So I will write negative m12. M12 is already found, which is negative 17. You can check from here. So I will put negative times negative 17. So negative times negative 17 is positive 17. Now this is the turn for A13. So I will again write the formula A1 negative 1 to the power 1 plus 3. 1 plus 3 is 4. So negative 1 to the power even number is plus. So I will write plus M13. M13 is already found, which is negative 6. You can check. So I will put negative 6 here. Now is the turn for A21. It is negative 1 to the power 2 plus 1. 2 plus 1 is 3, which is odd number. So I will write negative M21. M21 is already found, which is 0. So I will put 0. Now is the turn for A22, which is negative 1 to the power 2 plus 2. 2 plus 2 is 4, which is even number. So I will write plus M22. So M22 is already found, which is negative 2. So I will put negative 2 here. And similarly, we will find all of the other values. So all of the cofactors have already been found. Now we will find the cofactor matrix. So the cofactor matrix is written by A11, A12, A13 up to so on, all of the terms. Since we have already found all of these terms, from here we will put the values, which is this matrix. So this matrix is called the matrix of cofactors. Okay. Now we will find the adjoint. Since adjoint is the transpose of all of the cofactors, so I will write adjoint is equal to the transpose of the cofactor matrix. So if I take the transpose of this, so this row will be converted into column. You can check that the first row 8, 17 minus 6 is here in the first column. So the second row will become second column. You can check. And the third row will become the third column. Okay. So this is the adjoint of the matrix. Let us review again. What we have to do in order to find the adjoint of the matrix. First of all, we will find all of the minors. You know how to find the minors. For the minor Aij, we will delete ith row and the jth column, and the rest of the entries will be written in this determinant, and you will find this determinant. This will be the minor M11, and similarly you will find all of the other minors as I have found. Then is the turn for the cofactors. For the cofactor, I have the formula negative 1 to the power I plus j times the minor. So how you find A11, the first minor, negative 1 to the power 1 plus 1 times M11. M11 is already found. So this is you have to calculate. If this is odd number, then you will write negative. If this is even number, in this case, which is 2, you will write plus. So we will similarly find all of the cofactors. So once we find all of the cofactors, then we will write the matrix of the cofactor. The matrix of the cofactor can be written in this way. Since we have found all of the values above, so we will put all of the values here in this matrix that is called the matrix of cofactors. So once we have found the matrix of cofactors, then is the turn for the adjoint of the matrix, which is nothing but the transpose of the matrix of the cofactor. Okay, if you take the transpose of the cofactor matrix, you will end up with the adjoint of the matrix. This process is little long, lengthy, but this is easier to calculate. Once you will practice, everything will be fine. So next, we have the key property of the adjoint of the matrix. So for any square matrix A, we have A times the adjoint of the matrix is the same as the determinant times the identity matrix of order n by n. Similarly, if A times adjoint is this thing, then adjoint times A is also this thing. So this is the property which is used to find the inverse of the matrix. So here is the implication. So the implication is that if A is invertible matrix, which means that if the determinant is not equal to 0, then A inverse can be found by this formula, 1 by determinant of the matrix times the adjoint of the matrix. Okay, so in this way we can find the determinant of the inverse of the matrix. So this is the formula, which is very obvious implication of this key property. Okay, let's have an example. In this example, we have to compute the inverse of a matrix by using the adjoint. So this is the given matrix. We have to find the inverse of this matrix using the adjoint, and we are given that its determinant is -4. If the determinant is not given, then you can find the determinant by the formula which we have already discussed in the previous videos. Now our aim is to find the inverse of this matrix. What is the formula for the inverse? We have just studied that the inverse of the matrix is 1 by the determinant times the adjoint. Since we have already found the adjoint of this matrix previously in the previous example, the adjoint of this matrix is this, we have already found, and the determinant is already given. So we have everything. We will put the values. The determinant is -4, which is already given, and the adjoint of the matrix we have already found. So I will put the value directly. I will not find it again. If I divide each entry of this matrix by -4, then I will end up with this matrix, and after simple calculations we will get this value. So this is the inverse of the matrix A, which is given here. So this is very long process to find the inverse of the matrix. So previously we have already studied the method in which we find the inverse of the matrix using row echelon form by augmented matrix. That method is easier and this method is longer. This is also easier, but it has a lot of computations. Here we have another example. In this example, we have to find the values of M for which A has no inverse, and we have to find the inverse of the matrix for the other values of M. Here is the solution. So first of all, we will check for which values of M this matrix has no inverse. So in order to find those values, we have to find the determinant of the matrix. So that in order to compute the determinant of the matrix, we will choose the row or the column which has the most number of zeros. So we will expand this determinant along the second row, because in the second row it has 2 zeros and only one non-zero entry. So along the second row, the determinant of the matrix is, for the first value M11, this value, it is On the second row and the first column, so I will write negative 1 to the power second row plus first column, which is negative, times m. So if I delete this column and this row, I will end up with 1 m1 1m square. So I will write this thing here and I will compute these values, and after simple calculations I will end up with negative m to the power 4 plus m. So a has no inverse when this thing is 0 because this is the determinant. And if the determinant is 0, then A has no inverse. This is well-known fact of the matrices. Now, if I take common m from these two values, I will get here 1 and here m cube. So I will write m times 1 minus m cube. I have just changed their values, their positions. Okay. So now either m is 0 or this value is 0. Okay. So if m is 0, then there is no problem. If this is 1, so if this is 0, then it is m cube is equal to 1. Okay. So we have two values of m, either 0 or 1. So for these two values of m, we will say that A has no inverse. Okay. So if m is not equal to these values, then A is invertible. So we want to find the inverse of A for the other values of m. So in order to find the inverse, we need to find the minors first. So first of all, we will find the first minor m11. You know how to find the first minor. The first minor can be seen by deleting this, and by deleting this, we will end up with this. Okay. So the first minor is 0. So similarly for the second minor, we will write 1 2. So the one first row and second column, second minor is m12. So first row and second column. So the rest is the second minor. You can check that the rest is the second minor. If I calculate its value, it is equal to m cube. Similarly, m13 is this, and m1 and 21 is this, and the rest of the values are here. Okay. Now we compute the cofactors aij, which is negative 1 to the power I plus j times the minors amij. So the first one is a11. So by the formula, it is negative 1 to the power 1 plus 1 times m11. Since m11 is already found, which is 0, so its value is 0. Next one is a12. By the formula, it is negative 1 to the power 1 plus 2 times m12, which is equal to negative m12, because negative 1 to the power 1 plus 2 is 3. So whenever negative 1 to the power is odd number, then it is negative. So that's why I have written negative. m12 is already found, which is m cube. So I will write m cube. Similarly, a13 is negative 1 to the power 1 plus 3 times m12. Since 1 plus 3 is 4, which is even number, so I will write plus m13. So m13 is m, which is already found. You can check from here. Similarly, a21 is equal to negative 1 to the power 2 plus 1 times m21. Since this is 3, so negative to the power odd number is negative. So I will write negative m21, and m21 is m cube because it is already found previously. And similarly, you will find all of the other values. If I put all of these values in the cofactor matrix, I will end up with these values, because I have found all of these values here, put these values in the cofactor matrix. So this is called the matrix of cofactors. So if I take the transpose of this cofactor matrix, then I will end up with the adjoint of the matrix, because adjoint of the matrix is just the transpose of these cofactors. Now our aim is to find the inverse of A. So the inverse of A is can be found in this using this formula. So if I put the values, since the determinant of A is negative, m to the 4 plus m, we have already found previously. Here it is. Determinant of A is negative m to the power 4 plus m. So the adjoint of the matrix is this one. So if I write the value of the adjoint, so this is the inverse of the matrix, which is which was to be found, and this inverse can only exist if m is not equal to 0 or 1. Okay, because for those values the inverse of the matrix does not exist. Okay, so this is the end of the adjoint of the matrix. So in order to find the inverse, we need the adjoint and the determinant. So if you are able to find the adjoint and the determinant, you can easily find the inverse of the matrix. That's all.